In this video, we will take a look at area bounded by two polar curves. So here we want to find the area of the region that lies inside the circle, r equals 3 sine theta, and outside the cardioid, r equals 1 plus sine theta. So the first thing to kind of look at, let's just try to draw this out without having to do the reference angle or reference function. We can kind of see that this is going to be a circle. So this guy's a circle. It's 3 times as large. So we know that it's a circle that's hinged around the y-axis. So around the y-axis, it kind of looks like this. Okay. So that's that one. So this is going to be r equals 3 sine theta. And then the next one is a cardioid. So because it's a sine function, you can see that the cardioid is also going to be kind of hinged around the y-axis. So it looks kind of like this. Okay, if I can draw this correctly. All right, and basically what you want to find is the area of the region that lies inside of the circle. So it's everything in the circle and outside of the cardioid. So it has to be all of this area. Okay, you can kind of see that they're symmetrical as well. So you want to find that area. So one of the things that you have to kind of take a look at is where exactly is this intersecting? Because if I can find out what these two angles are, I can figure out where to integrate. So the way to do that is just setting both of this equal to each other. So 3 sine theta has to be equal to 1 plus sine theta. I'm going to subtract sine theta to the other side. And you're left with 2 sine theta is equal to 1. So then I'm left with sine theta equals 1/2. And then this is going to be when with pi equals pi over 6 and 5 pi over 6, I believe. Yeah. All right, so that's what we're going to get. So this is going to be pi over 6. And this is going to be 5 pi over 6. Okay. Now, because of symmetry, you don't necessarily have to go from pi over 6 to 5 pi over 6. You can. Another way that you can do it is just going from this area to this area and then just doubling it. So from pi over 6 to pi over 2. I mean, it might be helpful. The reason why I have pi over 2 is because the point here is going to be 0, 1. So maybe some things might go to 0. So that's the only time that I would actually recommend this. So let's first start out by finding our area. So our area is going to be equal to the integral from a to b of 1/2 r outer squared plus r inner squared. Okay. So, and this is going to be d theta. So first, let's start off by just putting it from regular pi over 6 to 5 pi over 6 with the original region, 1/2. Then we have our outer. So remember, I like to draw a little arrow from the pole all the way out. And you can see that the last curve that it hits is a circle. So this is going to be 3 sine theta squared plus the inner one, which is going to be the cardioid, which is going to be 1 plus sine theta squared. There should be minus. That would have been a huge mistake if this was a plus. Okay. So we're going to have something that looks like that, and then d theta. Okay, now what we can do is we can multiply this by 2. So this is going to be 2 times pi over 6 all the way to pi over 2. So now we're changing it to pi over 2. Then you have the 1/2. This is going to give me 9 sine squared theta minus 1 plus 2 sine theta plus sine squared theta, d theta. So this guy and this guy is going to go away. So you're just left with the integral from pi over 6 to pi over 2 of 9 sine squared theta minus 1 minus 2 sine theta minus sine squared theta, d theta. So I can collect these two guys. So it's going to be pi over 6. Pi over 6 to pi over 2. Okay, and then you're going to get 8 sine squared theta. Let me write the minus 2 sine theta first, and then minus 1 d theta. So now here what we can do the half angle formula one more time. So we have the integral from pi over 6 to pi over 2 of 8 1/2 1 minus cosine 2 theta. That's going to be it for that one. Minus 2 sine theta minus 1 d theta. So this guy is just going to give me a 4. So you're left with pi over 6 over pi over 2. And you're left with 4 times Let me just distribute the 4. So you'll just have 4 minus 4 cosine of 2 theta. Okay, and then minus 2 sine theta minus 1 d theta. So now let's collect the constant. So you're going to have the integral from pi over 6 to pi over 2 of 3 minus 4 cosine 2 theta minus 2 sine theta d theta. So now let's just take the integral of this guy. So you're going to have 3 theta minus 4 over 2 sine 2 theta, and then that's going to be plus 2 cosine theta from pi over 6 to pi over 2. Doing this all in my brain. All right, so then what you're going to do, you're going to plug this in, and what you're going to get is pi. Okay, so you can practice plugging that into the formula. Okay, now let's do one more problem. So let's try out set up the integral for the area shaded by r equals 2 sine theta and r equals 2 sine 2 theta. Here is the area. Typically what I will do if I give this in an exam, I will kind of just give you the area instead of just having to graph it. So one thing that I like to do is let's go ahead and extrapolate just the area so that we can kind of see what exactly is going on. So I'm just going to look at the circle. So notice that you have this petal. Let me just make it a little bigger so that you can all see. Okay, so you have this petal, and then you also have this circle. Okay, so what you kind of want to look at is figure out what is going to be this point of intersection. Okay, so that point. So maybe let me draw the circle a little bit bigger. That way you can kind of see what I'm going to do. Make it a little bigger. Oh, God. Okay, that was too big. Okay, so let me try to make this so that I can, okay, there you go. Okay, that's a little better. Okay, so let's say you have that area, and notice that the area is not going to be halfway. Okay, so one of the things that you kind of want to think about is, okay, well, we want to find this area. You're definitely going to have to take 2 different integrals into account. So let's first start off with what theta should be. So what is going to be this angle theta? So the first thing that we want to do is let's set this 2 equal to each other. So we're going to divide by 2, so we have sine of theta equals sine of 2 theta. In this case, it would be a good idea to make this and find our trig identities. Okay, so you're going to have sine of theta, and this is sine of 2 theta is just equal to 2 sine theta cosine theta. So let's subtract this out, so you'll have sine of theta minus 2 sine of theta cosine of theta is equal to 0. Going to take out a sine of theta, and you're going to have 1 minus 2 cosine of theta equals 0. So I can try to make this sine of theta equals 0, and 1 minus 2 cosine of theta equals 0. So here theta is going to be equal to 0 and pi, and here cosine of theta equals 1/2. So theta equals pi over 3 and 5 pi over 3. So notice here that cosine, you're basically going to look at the cosine, which is pi over 3. So this guy should actually be pi over 3. Okay, so we kind of already figured out what that's going to be. Now notice this is a tricky problem because this is not an outer minus inner problem. You have to be kind of smart about it. So let's divide this area. So let's divide this as the green area. So it's going to be this green area. And then let's divide this other one as the red area. Okay, so you have 2 different areas. So the first thing that we have to look at is look at this green area. So I'm going to use this yellow marker. So if I just look at the green area, so let me draw an arrow through the green area. So I'm going to draw an arrow from the pole all the way to the green area. So notice that there's no inner function. All you're just tracing out is just this graph. This graph belongs to the circle. So if I want to find the blue area, so the green area, is going to be just basically the circle. So right now the area, so the total area should be the green plus the red. So area is going to be the green plus the red area. So the green area, if you see, is just going to be this circle. Okay, so this circle is going to be the green area. So that's just going to be the integral from 0 to pi over 3, because that's how, 0 to pi over 3 of 1/2, and then the equation of the circle, which in this case is going to be 2 sine of theta squared d theta. That's going to be the green area. Okay, because the circle starts at 0 and then goes all the way to pi over 3. Then from pi over 3, we're going to look at this red area. So let me use this yellow marker again. Started from 0, drawing a little arrow through the red area. So the red area here corresponds to this curve, and this curve comes from the rose curve. Okay, so basically from pi over 3 all the way to where? Okay, so it starts at pi over 3, then it goes to pi over 2. Okay, that's where it ends. This is going to be all of this area. Okay, so it's going to be equal to plus the integral from pi over 3 to pi over 2 of the red area, which is going to be 2 sine of 2 theta squared d theta. Okay, in this case, we just wanted to go ahead and just set up the integral. So this will be my integral. So sometimes some areas are not going to be outer minus inner. You're going to have to be very smart about it to try to use some sort of geometry to try to figure this out. And it's not going to be double the area because you have two different graphs in this case. Okay.